Hello, let's continue. So the good thing for this approach is um, my next weight will never pass the minimum point because it can see if the gradient will be uh, gradually reduced to zero, and this if this guy is very close to zero, so and the W2 will be very close to W1, and then I can get a converged final solution for this one. So here uh, is how I want to do the, the programming. So I started with the initial value W, and I do the iteration. And then for each W, I can calculate the Y value, and then I can calculate the cost, which is the mean square error. And then if I would see if my cost is equal to zero or I, the value gets saturated. If yes, I can stop. If no, I will calculate the gradient, and the gradient will be applied to calculate the next uh, weight, and then I would go back to the initial status, which is the loop I can do. Okay, let's do a demo with Python. So here let me see. Here I did this with Spider. I didn't do it in the virtual model because virtual machines are because the virtual machine is much slower, and I couldn't run this code with in the virtual machine. So let me see if I could run this one. Yep. So basically, I'm doing here for each iteration, I'm replot this curve. You can see it moves, and the final is it looks like still running, but looks like it's getting saturated in the minimum position. Oh, it's done. Works. So let me go back to my presentation. Um, so the next problem is a little bit more complicated. So here you can see it not only has one weight, you also have a b value, which is a bias, and there's another parameter you need to tune to get a perfect regression model. How do we do this? So we'll follow the same procedure, but we also have to consider about the b value here. So the w will remain the same. So here's the cost will still be the same, which is the mean square error, and the w will remain the same. But b, we have to calculate the gradient for b, and you can simply see, and here I calculate the gradient for b, and then I will have two learning path, one for w and the other one for b. So this one will be the previous w minus the learning rate times the gradient, and b will be the previous b value minus the learning rate times the gradient for b. So the loop will remain the same, but I have one more variable to consider. So I'll set the initial w and the b, and then I do the loop to calculate the initial value for y, and then calculate the mean square error to see if I get a minimum cost or it is saturated. If yes, I can stop. No, I will repeat the same thing, and I will calculate the gradient, update the weight and the